everyone, it is so good to have you here. I am so excited you logged on to this program. And today we're going to be making a bionic hand. If you don't know what that is, don't worry. We're going to be learning that as we go. And what we're going to start with today is, what is engineering? You may have learned a little bit about engineering or engineers in school, but we're going to talk a little bit more about what engineers do. And then we'll talk about how we're going to use that information to make our own bionic hand. The first thing we're going to do is watch a short video on how engineering is part of our everyday world and how we need it no matter what we do. So we're going to watch the first couple minutes of this clip.
Let's take a moment to think about your morning. The alarm on your phone goes off at 7:03. You drag yourself to the shower and blast yourself with perfectly warm water in an attempt to wake up. You smear your toothbrush with too much toothpaste and scrub yourself into a foamy mess of minty freshness. You're running late, so you skate downtown, weaving through the commuters, dart across the road, barely making the lights, and jump on the train just before the doors beep shut. There's a couple of stops to go, so you pull out your phone and play a few games of Angry Birds. Alarms, trains, traffic lights, video games, toothpaste, all these things were made possible by engineers. But what prompts an engineer to improve our world? Well, they solve problems. Problems are an engineer's inspiration, and maths and science are the creative tools they use to solve them. Problems like making your alarm go off at the right time, or making sure your toothpaste has just the right balance of chemicals to give you that perfect smile, or even making a game so addictive it's almost impossible to put down, if that really is a problem. Now let's head over to the airport and jump on an aeroplane. Aeroplanes. They're so easy to take for granted. But don't forget, you can fly. Before aeroplanes, flying was quite a bit more challenging. Every bit of your plane has been touched by engineers. A mechanical engineer designed the engine. A mechatronics engineer devised the controls. The fuel? Extracted by mining engineers and refined by chemical engineers. The navigation systems? Electrical and software engineers created those. Yep, a whole team of engineers.
Okay, so here you can see how engineering is used for everything. So on the next slide, we are going to talk about what we are doing today. We heard from the video that engineers solve real-world problems. Real-world problems or ways to make our world better. So let's do one ourselves. This is a real-world problem that happens to humans and animals across the world. It is the loss of a limb. So we are going to meet the bionic chef and look at how science, technology, and engineering have helped so much with his loss of a limb.
He's had his new hand for less than 24 hours, but the Seattle-trained chef from Bozeman, Montana is getting the hang of it.
Control's good. It's almost too smart for me right now.
Still, Eduardo Garcia is already able to deftly slice a thin vanilla bean, chop, and more. It helps that Chef Garcia is right-handed and that it was his left hand that he lost. Still, cooking requires two-handed dexterity. Garcia came to Portland to Advanced Arm Dynamics to be fitted with his new prosthesis. This bionic hand is the latest and greatest in the rapidly evolving field of prosthetic technology. The sleeve of the bionic hand fits tightly over his skin so that his skin connects with electrodes in the prosthesis. That allows Garcia to use the muscles in his forearm to control his new hand's movements.
Okay. Wow.
The outside muscles or the extensors are going to be your open.
Sure.
The inside muscles or the flexors are going to be your closing.
That was me telling it to do that, huh?
He can even splay his fingers and use his thumb. The hand can grip in 25 different ways. It is motorized, wireless, and uses Bluetooth technology. And while it's not completely natural, it's as close as engineers have come. Mac Lang is working with Garcia to meet the chef's needs.
I go in and look at the microprocessor in the hand and make sure that all of the settings match sort of what his abilities are and sort of fine tune it for him.
Precision pinch, that would be
And the prosthetic does not weigh Garcia down. His bionic hand is about the same weight as his real hand. It is made of silicone and carbon fiber and fitted with lightweight lithium batteries that can run an entire day without being recharged. And if Garcia can no longer flick his wrist, he can at least twist it.
The task. So you are ready to try it yourself. Use the supplies you see to create a bionic hand. So you're going to create it first. Then, once you are done, challenge yourself to see if you can make each of the fingers move. And when I say make each of the fingers move, I don't mean move them with your other hand or move them yourself. I mean use the bionic hand, figure out how to move it from the impulses that it will have. Then see if you can make them move all together and pick up a small object. Here are some examples of how it could or should look in the beginning, just so you can get a visual. So you have your main hand, and then you're going to be putting things inside of it in some way to turn it into a moving hand. Some examples of finished hands. You can feel free to refer back to these whenever you want to. You can see here on the top left how all the fingers have been connected to help them move individually and together. So I just want you to have fun with this. So on the next video, I will explain exactly where to start. Okay, everyone, so you should have a packet and it looks like this. These are all the components you need to make your mechanical hand. So first, just like in the PowerPoint, it says design and build a mechanical hand model with moving fingers. You have materials that include what is in your box, which is your bag, plus scissors. So please go get some scissors now. Pause the video if you need. Then we have something called constraints, and I talked about this in the PowerPoint. The hand must have movable fingers and a movable thumb, and each finger should move independently and all together. It does not have to grasp, but it certainly can. So what I want you to do now is go through and get your planning sheet, and it should look like this. And I have started, this is not what yours needs to look like, and I've only labeled a few things, but the directions are design your bionic hand here. Engineers always create a design or a blueprint before they begin, so we are no different. After that, you're going to draw and label each supply you will use. So I started here, it's just an idea, and there are more obviously, and this should be a blueprint of what you want the hand to look like in real life. So what I want you to do now is look through the PowerPoint again, look through your supplies, take a few moments, and pause this video. All right, so now if you're watching this video, it should be because you finished your bionic hand. And so what I want to do is give you a few ideas of examples that I did, and you can decide how yours did also. So the first one I did is an example of how you can use pipe cleaners. You can move it to make all the fingers move together, or you can just hold and make a finger move individually. This one you can use to help grasp things. The next one is a little different design. You may have done this one or something different. It's totally fine. And what I do is you pull down on the string to make the bionic hand move its fingers individually, just like you move your fingers individually, or you can grasp the whole thing and make them move all together. All right, great job, guys. I hope you had fun. Have a great day.